Hello everyone and welcome back. Today I'll be showing you how to build a house of quality from scratch in Excel. Now in the first half of this video I'll be talking about the house of quality in general, how and why it's used, and how we use it at Bevel Edge in our product research. And in the second half I'll be building a house of quality live from scratch in Excel, and this will allow you to follow along and replicate it as you need. Okay, with all that said, let's get started. The house of quality is actually step 3.4 in our ultimate product development guide, which consists of 17 steps, and this is a free PDF that you can download from our website. And the whole purpose of this product development guide here is to help students, project managers, project engineers, product managers, and entrepreneurs understand kind of the top level view and some tidbits about complete product development, from product idea all the way to actual design support and manufacturing. So this is for you to download our website. Go ahead and check it out and we can get started with the rest of the video. So while the ultimate product development guide that we provide on our website is a practical approach, there is the academic approach to engineering design written by George E. Dieter and Linda Schmidt. So we are referencing this book here and pulling some illustrations, and the house of quality that we use at Bevel Edge actually comes directly from this book with its description and qualities coming straight out of there. So let's look at when and how you should actually start using the house of quality, when the right time is. And in our product guide, we expect the ultimate product to have the house of quality completed and utilized in step 3.4, so pretty early on in the design stage. This is part of the product research to help you understand what to build in the first place and what are some of the requirements and controls that your product must meet before moving forward to actual design. Now, in the engineering design book, figure 1.1, very early on, let's see, let me get my pen out to highlight it. They are showing two approaches to product design, and they're split up into different stages, so market development, conceptual design, product design, manufacturing, and actual product use. And they have two lines here that describe the amount of cost that you will spend for your product. Now, inevitably, there is a minimum amount of cost that is needed to launch a successful product, so one way or the other you will meet that minimum amount. And the house of quality that we're talking about should be actually deployed here early on in the design stage, as we said, part of the market development and market research. And in the book itself, they are splitting it as defining the problem and gathering information. So we have it split into 5 different points. They have it just in the first 2. Okay, back to this graph here. You want to spend a decent amount of time researching your product, researching your market. Then you want to spend an equal decent amount of time conceptualizing it and iterating it on paper, PowerPoint, before you actually move into the design stage. That's when you're paying an engineer or a professional to actually design your product. And now if you've done a good job here, this should be pretty straightforward. Now at Bevel Edge, we specialize in this area of product development. While we do help our clients with the other 2, this is our bread and butter. And if you have a good design, then the actual manufacturing should be pretty straightforward with very little hiccups or surprises. And then when it reaches in the customer's hands, there won't be any weird issues that you would have to go back and redesign and fix problems. Also known as recalls. Like in the automotive industry, it's kind of a big deal. If there is a safety issue with the vehicle, they call for a recall and go back and fix the vehicles that have issues. Now, contrarily, there's approach number 2 here, or the alternate approach, where you kind of go with the gut feel of, hey, I want to create this product. I think it's going to do great. You do very little amount of concept design, and you spend a decent amount for an engineer or a firm to design it for you, or even a designer, and then you go into manufacturing, and that's when you actually start spending your money, is in the manufacturing. Once it gets to the hands of the consumer, you'll get feedback about features or problems that your product has, and you have to go back and redesign, forcing you to spend even more money. Now at Bevel Edge, we think the best approach is as such, where you spend a decent amount of time conceptualizing and market developing your product, and you spend a decent amount of time designing it properly. And once you've done so, then the rest should be smooth as butter. So this is kind of the trajectory that we use here at Bevel Edge, because we specialize in product design mainly to begin with. Okay, with all that said, let's move on to the rest. Okay, back to step number 3 from the Ultimate Product Guide, the product research stage. So in the product research stage, you want to conduct a preliminary market research. This is talking about the fundamentals, market technicals, market dynamics of the project or the product you're trying to develop. And then also you want to conduct a benchmark study, and basically this is you purchasing or getting your hands on similar products or competing products out there and see what kind of standards that those meet. What are some of the coolest, newest things that exist, and what are some of the expectations that a successful product might have. All that comes out of a benchmark study. Then in 3.3, you do a customer research. This is where you phone maybe 100 potential clients that meet your demographic that you're targeting your product to. You interview them, ask them questions, and kind of get their input on what their requirements are for an ideal product. And the house of quality comes next, step 3.4. So basically you have these different market analyses, so market study, benchmark study, and customer research analysis that you've done. And the question is, how can you put it in one useful single page view such that you can share it with the engineers, with the designers, with the marketing team, and ultimately come up with a good product? And that is where the house of quality comes in. So the house of quality is the one pager that summarizes the key details from your product research and puts it on a single page. Now, let's see. Looking at figure 1.5 of the engineering design book, this is an interesting graph here, and it's worth mentioning and talking over it. So on the x-axis, you have time into the design process. So this means the more time you spend researching and developing your product, and on the y-axis you have percentage. That's just the percentage of knowledge or the percentage of design freedom that you think you have. What happens early on with newer customers or a new product, you're at this vertical line right here, where the knowledge about the design problem is very, very limited. So we kind of have an idea of what we want to do. Therefore, we think there are many options that we could create, and those products would still sell. And as you do your market research, your benchmark study, customer research, and a house of quality, what happens is your knowledge about the design problem increases. Now, as time goes on and you conduct your studies and your market research and you do your iterations, your knowledge naturally increases. And what happens naturally is your design freedom starts to diminish over time. And that is a function of your increased knowledge. Whereas here, you just thought you could build whatever and it would sell. When you get to this stage of your knowledge and your design process, you kind of tell yourself, hey, look, I've talked to the customers, I've did the market analysis, I've done the study for manufacturing and failure modes, and realistically, there is only one configuration of this product that can be successful. And this is not necessarily a bad thing that your design freedom decreases. This just means that based off your knowledge, you're optimizing the final product. And that is a good thing because it is a refined, well thought through and balanced product that actually will sell. So this is something that you're looking for out of your product research stage, section 3.1. And the house of quality will put that together in a one-pager for you. Moving on to figure 1.4 of the Engineering Design 5th edition, there is this interesting figure, and I want to walk through this one as well with you. And this talks about the design point of view of individuals who are a part of your actual design process. Now, they're using the example of a swing, so let me kind of talk to that. The customer who comes to us at Bevel Edge says, hey guys, I have this great idea. I want to create this product. And they tell me, look, swings are inefficient. Only one kid can sit on it at the same time. I want to build a swing with 3 little seats. That way 3 kids can sit on it and have 3 times the amount of fun. Perfect. Then they get together and explain the product and make a formal project request. And in the request, the description of this triple swing gets interpreted as such. And now, because the product manager thinks that maybe this would sell better than that based off the limited information they have, then they send this information over to a senior design engineer. And here is what he says. He says, well, look, you guys are trying to create a product, but it's inherently unsafe. If I tie the rope on the thickest part of the tree stem, the stub of it, then there's no way this rope would break. There's no way this tree would break. Versus if I attach them up here at the limbs, there's a higher chance of it breaking. And I'm going to put the end loose on the ground so no one can potentially fall off the swing. Now, the engineer, based off his limited knowledge and what's simple for him and what makes sense to him, designs this configuration. He creates a design and moves it forward to manufacturing. Now, the manufacturing engineers get their hands on this and they think to themselves, well, we know the swing has to be able to swing back and forth, so what the engineer designed doesn't make any sense. We're going to attach the rope to this side on this branch and to the left side on the other side of the branch. And that is because it's easy for us to manufacture. That way we have the tool that can do that. And it's still kind of safe because now you're hanging on 2 branches instead of 1 branch, so it's double the strength. And you still have the ability to sit on it. Then the product goes out the door and in the hand of the customer, and the customer is installing it. Now, they wanted a swing that can actually swing back and forth, and what the manufacturers built is this. And so the customer is forced to cut their tree in half, supported with arms, such that the swing can actually swing back and forth. So this actually was the function that the customer was looking for, a swing that swings back and forth. That's all they really cared about. They didn't really care about their triple seats, or this didn't work for them because it didn't swing at all. This also didn't work for them. It was great for manufacturing, but that's what they wanted. It was a swing, and they're forced to install it in such configuration. Now, if you've done your due diligence and asked the customer what they really wanted and willing to pay for, this is the answer you would have gotten. They just wanted a tire swing. They didn't care about sitting on a board at all. So the House of Quality will help you go from this concept through all of these iterations and help you sooner land to the final version that the customer is actually willing to spend their good hard-earned money on. And that is the power and value proposition of doing a House of Quality. Okay, now that we've spoken about this, let's move on to the next point. Okay, this is the most complete configuration of House of Quality as described in the 5th edition of Engineering Design by George Dieter and Linda Schmidt. This starts around page 100. It is figure 3.6. So this is like the full configuration of the House of Quality. Now we at Bevel Edge add on to this and make it even more complete than what this book suggests. So let me show you what that looks like. I've color coded this here. This is the Bevel Edge version, and what we've done is we've added room 0. Room 0 is a qualifier of what kind of characteristics these requirements are. That's coming from the Kano diagram, which I'll explain later. So we break our House of Quality into an additional room, and this is what the configuration of it is. The basic point of the House of Quality, if I had to sum it up, is requirements from the customers and how important these requirements are from the customers. Engineering characteristics, the things that you control as a designer or as a product manager or as an engineer, and how the customer requirements and the things you design correlate to one another. And then here are the competitors. You can see, if you've done your market research and your market analysis, you can see what the competitors have, and you can compare those to the customer requirements. And when you have the things you control, the things that customers want, and you correlate them to each other, like so, the output will become an importance ranking. So the importance ranking will be each individual characteristic that you can control and how important each one of those is to the final product and what the effect it has on the final product such that the customer wants it. And then there's technical assessment, which basically says how difficult each one of these is to meet, and the target values that you're aiming for. And if you aim for the correct target values based off of your relationship matrix, you should finally get a good product. Okay. So back to room number 0 here. What do we add in here in room number 0 that makes the house of quality even more complete? Now we add the Kano diagram. So the Kano diagram in engineering design book is figure 3.5, and it breaks down the requirements, so the customer requirements, into 4 different categories: the exciters, performers, expectors, and the ones that are indifferent. So let me explain these 4 lines or 4 aspects to you. Let's talk about an autonomous tractor. So this is a tractor that doesn't need to have a farmer or an employee sitting on it to perform its work. It's out on the field, and it, through satellite communication and GPS, can follow its track and do all the work autonomously, which is great. So the question is, when we talk about customer requirements, what are the qualities of the customer requirements? Now, they are how important they are to the customer and what their qualities are, the classifications basically. So let's start with line number 3, the exciters and the delighters. Well, actually, let me talk to this graph a little bit. So on the left side of the graph is, so anything on the left side is something that's absent, that is not included in your design. Okay, these are things that are absent. On the right side is fully implemented, so that is 100% baked in the cake, full on effort, and it exists in the product. At the very top, you have a satisfied customer, so this makes the customer happy. So you want to be up, and low is a dissatisfied, disgusted customer. So the customer is like, man, what the heck is this product? This is BS. I don't want it. I don't care for it. I wish to get my money back. So if you identify that a customer requirement is an exciter, it will fall on this line. So in case of an autonomous truck, the autonomy capability itself is an exciter, because if you, now the function of the exciters is exponentially in the upwards direction, which means that you don't need to fully implement the autonomy. As long as it has some autonomy, you will move way up here. And that is good because it makes for a happy customer. Now, is autonomy perfect? No, it's not, but it's included. That's going to be a deal breaker for them if it's not there, or it convinces them to buy the product even more so if you have just a little bit of autonomy. Now, what falls on the performance when it comes to a autonomous tractor? Now, performance could be speed, fuel economy, and basically this means that if your fuel economy is bad, if it's wasting a lot of gas or diesel, then you have a low satisfied customer. But the more effort and time you put into the speed of the tractor, the mechanical performance of the tractor, the more delighted of a customer you will have. So when you identify that a requirement for the customer lands on number 2, it still makes sense to put a lot of time and engineering effort towards it, because the more time you put into it, the higher on the graph you go. Versus something that are the exciters that we just talked about previously, it does not make sense to spend more time on the exciters because it does get the customer excited right away, so there's no point in getting them more excited. They're already willing to pull the trigger and buy the product. Now, if your exciters is not included, it's not necessarily a deal breaker, but it's not ideal, so you end up somewhere here. So the exciters, put some decent amount of effort into it, make sure it includes the performers. The performers spend a lot of effort into it, and make sure the performance of your product is good, because the more time you spend in it, the more linearly, the more benefit you get out of it. Next, you have the expectors. So those are the threshold requirements of the product. What would that be for an autonomous tractor? Well, that is maybe corrosion resistance or serviceability. How easy is it to swap out these giant wheels? How corrosion resistant is it? If you don't have your corrosion resistant included, I mean, what's the point of having an autonomous truck if it always corrodes and is broken down, or I can't service and swap the wheels? So this thing on the green line needs to be 100% implemented for your customer to even consider your product. Even though they're excited about the autonomy, even though the fuel consumption is great and the speed is good, if it starts to corrode, then they're not going to pull the trigger. They're going to be dissatisfied with your product. So what this means is that you need to spend a healthy amount of time on the expectations of the customer. That comes from the benchmark studies, right? So the expectors need to be fully implemented so that you are at least somewhere on the more satisfied. So you come from the down here to higher up to a more satisfied customer. But now here's one thing you need to know about line 1. No matter how corrosion resistant or how easy to service your autonomous tractor is, that is not going to be a deal maker and get the customer excited to buy it. So these things need to be included, but they'll never be the reason why someone will buy your product. Okay, so that means you spend a decent amount of effort on this. Once you get them to the threshold, you stop. Spend most of your time on the performers and a decent amount of time on the expectors, and make sure you have your expectations, your expectors up to par with the market standard. Now there are some things that are indifferent. So let's say maybe it's the color. This could have been blue, orange, or green. That would have been indifferent to the customer. The farmer doesn't care. He just wants a tractor that performs for him. So this counter diagram, so the classification of exciter, performer, expector, and indifferent is listed in our version of the House of Quality right here in room number 0. That way you know what kind of expectation these are and how important they are. Okay, moving on. All right, now that we're ready to actually build a House of Quality from scratch based off of the previous discussion that we had, I want to propose creating a House of Quality for a coffee mug. So let's do a coffee mug quality function deployment. And what we're going to say is that we've done our market research and we found this red mug that's pretty popular. There's also this Yeti mug made out of stainless steel versus the red mug made out of ceramic. And then we also found this coffee mug or coffee cup made out of clear glass. And the question is, what kind of coffee mug should we create such that it can compete in this environment based off the customer requirements? So let's do a basic House of Quality for a coffee mug, and let's switch over to the screens. We'll move over to Excel, and I'll show you how to build one completely from scratch in Excel. Alright, here we are in simple Microsoft Excel, and I want to show you how to build a House of Quality completely from scratch as a speed run. So I'm doing everything here, so hopefully you'll be able to follow and copy exactly, and that way you'll have your House of Quality as well. The first thing I want to do is insert the image of the House of Quality such that it is described in the book. So let's make this a little smaller. So this is our version of the House of Quality that we're baking, and this is kind of my visual guide as I'm building this. Okay. The first thing I want to do is create a new tab and call this ranking. So let's just call this rank. And then sheet number 1 is going to be a House of Quality, HoQ. So now we have the ranking and the House of Quality. And in my ranking, here are some of the things I want to list. I want to create basically a list. First thing I want to do is an aim direction. Okay, then the next thing I need to have is, well, let's fill out the aim direction. So the aim direction is usually with created with arrows. So if you go to your symbols and start to scroll through here, you'll find some of the up and down arrows. So you want to have an up arrow for the increased aim direction. You want to have a down arrow as well. Let's add that. Okay, and then there is also a neutral where it doesn't matter which direction it is. That can just be a circle. So here's your aim direction. The next thing you want to do is your importance ranking. Okay. And these are the values that you'll use for your importance ranking, and they're just simply 1, 2, 3, 4, and 5. Okay. So this will help you kind of automate your House of Quality. And then the relationship rating. So the relationship rating in the House of Quality as described is on an exponential chart. So it's 0, 1, 3, or 9. So that relationship is exaggerated. So no relation, some relation, moderate relation, and high correlation. Next you have is your technical difficulty ranking, and that is simply just 1 through 10. Okay, so this is kind of the foundation that we need. Then you have your technical correlations. So your technical correlations are going to be strongly correlated, somewhat correlated, negatively correlated, and strongly inversely correlated. So you put your apostrophe, and then you do a plus, space, plus, and then you just do a plus sign, minus sign, and then you do an apostrophe, minus, space, minus. So strongly correlated, somewhat correlated, inversely correlated, strongly inversely correlated, and obviously if it's blank, there is no correlation whatsoever. Now going back to the Kano diagram is the perception, the customer perception, right? So you have the exciters. Is that an exciting requirement, right? And you have the performance requirement. You also have the expected and the indifferent. Okay, let me quickly do a spell check. Make sure we've spelled all these correct. Yeah. All right, sounds good. So this is now on our ranking. So we'll be pulling from these lists, these few lists that we've created in our house of quality. Okay. Now that we've got that out of the way, let's actually start to build the house of quality, starting with room number 0. Well, I guess we need to format it correctly first. So one thing you can do is create squares instead of these rectangles out of all the cells. So click that triangle at the top, right click on it, column width, let's make that a 5. Okay, and then click back here, click on the row heights, change the row height to 30. So if you have 5 here and 30 here, you have perfect little squares, and that will help you with the geometry for the house of quality. So you want to scroll down, kind of get close to maybe row number 25 or so. So let's start over here and start building out room number 0. So for room number 0, I'll highlight 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 different cells, and I'll merge and center them. And for the coffee mug, let's say we have 5 different requirements that we care about. All right, so 1, 2, 3, 4, 5. I will outline these completely, and let's follow the color code and make them dark blue. So let's pick a nice darker blue. So that is this room right here. And then you have the actual customer requirements. So let's highlight, merge, and center some cells here. So these will be the customer requirements, and these are light blue. Okay, that matches, and let's outline them. So in the classifiers here, you kind of want to pick them off a list. So let's highlight all of this and then go to data, data validation. Okay, and then let's pick list and then find the source of this list. So hit this little button here. Now you can go into the ranking. So that was the this list right here, right? These are the requirements or the type of requirements that the customer has. So if you highlight them, hit that button again, hit OK. Now when you go back, you can select from the drop down menu, is this requirement an exciter or a performer, right? And so let's see, the font is kind of difficult to read, so I want to pick a nice bold font. Let's see, yeah, this one looks good, and then we'll increase, yeah, so to size 14. Okay, so this is kind of what you should see. Let's see if I can find even a better font. So Arial Black, yeah, that's a pretty good one. So let's make the entire thing Arial Black. Okay, I'm gonna change this color here. It's a little too dark. Okay, so here we go. Now here you list out your requirements. Next is the importance rating. So this part of this room. So for this, I like to highlight 3 little squares. Okay, so let's do that. 3 of them at least. Merge and center, and then you can copy and paste these like so. Okay, and that is green in our case. Let's make this green, light green. And the importance rating, if you remember, it was on a scale of 1 through 5. So we'll highlight all these. Again, same thing, go to data, data validation, and then pick it from a list. And this list was the importance ranking 1 through 5. Hit OK. So now you can decide what the ranking of that list is. Right? If it's like super important to the customer, it's a 5. If it's kind of important, it's a 1. Okay, now here is what I want to do. I want to conditionally format this so you can have a bar. So data bars, let's make some green data bars. Let's make the background actually white so you can see the data bars, and that's just kind of like a quick little view in addition to the numbers. So now let's go up 1, 2, 3, 4, 5. Yeah, let's merge and center these. So this becomes the importance ranking 1 through 5. So you want to right click on this, do format cell, and then alignment, change that 90 degrees. Okay, and you want to wrap the text. So here's your importance ranking. Let's make that actually green. Yeah, that's the light green color here. Okay, now this will start. Now it's starting to see. So you have room 0, 1, and let's make room number 2 next. So room number 2 is going to be the engineering characteristics. So for these, you want to have at least, well, you want to do 5. 1, 2, 3, 4, 5. Okay, as a not 5 cells, so 5 columns in a row. So merge and center these. Okay, that's kind of how you want to do it. So 1, 2, 3. Let's do 7 of those. 4, 5, 6, 7. So now that we have these 7 requirements, and these are in red because this is room number 1, let's go ahead and turn this into a nice reddish color. So I think this is a pretty good red. So that way we know what part of the house that is. And our units and such will come next. Well, I think first we need to distinguish what this column and this row is. So what we'll do here is we'll highlight, a couple of cells, merge and center them. And what you want to do is right click, format, and go to border and put this slash in here. Okay, the slash will kind of split this in half. So these are the technical requirements and these are the customer requirements. So you want to come in here and write down, so technical requirements, and you want to hit Alt space 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 space, and then these are the customer requirements. Okay, let's see what that looks like. Okay, so let's go back up. So if I expand this, I can go to my technical requirements, space couple over. Okay, see what that looks like. Yeah, so my technical requirements are here, my customer requirements are here. That cell can just stay white like it is. And now here come our units. So let's merge and center this. Units, and our units are all in gray, as you can see here. So let's merge and center these. So let me kind of copy that over. Okay, I'm gonna put this over here on this side so you guys can see. Let's go ahead and create a border for all of these, and we said these were all gray. So this is this part of the house. Now improvement direction, that is kind of the arrows, like do we want to maximize, minimize, or do we even care? So that should probably merge and center too. So let's quickly merge and center this, and that's kind of orangey, so let's pick a orange color here. So improvement direction, and then I guess we can copy the unit cells right above. Okay, but all of these are supposed to be orange, so we'll match that, give them a nice border. Okay, so that's this part. We got the units, and I think we can move to the correlation matrix actually. So for the correlation matrix, same story. We'll merge and center some of these cells so we match the rows with the columns. So copy this, yeah, and these can get borders, and they are going to be a neutral yellow, so this kind of yellow will work. So that is room number 4. Okay, let's build the customer assessment. So this is our market competitors. So here, let me highlight a handful. Well, here's what I can do. I'll first create a little box, so make it a square right here. So 1 2 3 4, 1 2 3 4. I'll merge and center that, and I'll copy and paste 3 of them over, and because and then I'll merge and center these here, and you guys will see why. So copy, well, I think I should merge and center this entire thing as one. Okay, and this is going to be our customer, our competitor customer. Competitive customer rating, and these are all in purple. So let me quickly spell check as we're going, making sure. Oh yeah, that needs to be changed. Requirement. Okay. So this entire cell gets a border, and let's see. This is the name. I think here we go. Let me put a border on all of these so you guys see what kind of formatting I'm doing. All of these need to be merged and centered, so that is going to be the name of the product. Okay, and this is the Yeti cup, and this is the clear cup. Maybe these need to be completely white. Okay, so as I'm comparing my customers' products to what the customer, the competing products to what the customer requirements are, I think I should merge and center these two, and we can put a picture in here that usually helps people realize right away what we're talking about, which kind of product we're comparing it to. So this is kind of the format. These all are going to be listed from scale of 1 through 5 as well. So let's go to data validation like we did in the previous steps, from the list, and then we can pull up the list. So it's an importance ranking 1 through 5, hit OK. So now we can go and rank them based on what the customer thinks this product is doing. Now we want to do insert picture in the cell from the device. So let's see. So this is the red mug that goes in here while it's loading. And then of course the Yeti. And then the clear one. Okay, so see, it also helps have a little icon in addition to the icon in addition to the name of the product. Okay, so okay, now let's start to list out some of the requirements. And before we move on, I guess all of these cells are also from a drop down, and they are from 0 to 9. any value from the list, because we've made a handy dandy list, right, based off our ranking. That is from 0 to 9. Hit OK. So now you can decide the correlation value between those two. Okay, so let's start to actually fill this out a little bit. I'll move this out of the way. So requirement number 1 from the customer is low cost. They want a cup that is at low cost. Requirement number 2, they want it to look nice. What does that mean? I don't know. That's yet to be determined, so that's a little bit of nuance there. And they want it to fit in a cup holder. That's pretty important to them, right? What's the point of a cup if you can't carry it with you everywhere and put it in a cup holder? And then work with the coffee machine. Okay. And requirement number 5 is not hot to touch. Okay, so they don't want to burn their hand when they're touching it. So how important is the low cost to them? Kind of like a 3. They don't want to spend a fortune. It has to look nice. That's pretty important to them, but that is subjective. Has to fit in a cup holder. That is pretty important. Work with a coffee machine. That's not compromisable. That's expected. And hot to touch. That can be pretty good. So the low cost is a performance thing. The lower the better. Looks nice is an exciter. Fits in a cup holder. That's expected. Works with any machine. That's expected. And well, fit in a cup holder, you could always make it fit better, so that's a performance one. Not too hot to touch, that is also performance. And let's say yeah, so these are the kind of requirements that qualify these requirements and what type of requirements they are and how important they are. So that gives you a one-page pretty good idea of what you're dealing with when it comes to evaluating the customer's needs. So the house of quality is moving forward quite nicely here. Now, what are some of the technical requirements that we control, right? So we can control the weight of the cup. Let me take all of these and center them. And then one thing we can control is the diameter of the cup. We can also control the height of the cup. Now, diameter and the height create a volume, because how much volume is in a cup, that's important to them. What kind of material it's made out of. Ceramic, stainless steel, glass. And then thermal conductivity. And then also the color. So those are the things that we can control hypothetically. Now the units of weight are pounds, diameters is in inches, height is in inches, volume is in ounces. Material is, well, that could be anything. Thermal conductivity, that is K value, and the color is an RGB value. Okay, and what do we want to do? We want to improvement direction. So how do we know, is a high weight a good thing or is low weight a good thing? So that is going to be determined by our improvement directions, and this is going to be also something that we'll fill in from our little data set that we've created. Okay, so now we want to reduce the weight, and let me see, these errors are kind of hard to see. So what I will do is I will increase the font size. Okay, we want to reduce the weight. Do we want to increase the diameter? Not really. We just want to have the right diameter. Do we want to increase or decrease the height? That's indifferent. What we want to do is certainly maximize the volume. So the people want to have a nice amount of coffee to drink. The material, there's no improvement direction. That thermal conductivity, we want to decrease that. So we want it to be thermally insulated. So we're reducing the thermal conductivity. And in the color, there is no value that we're aiming for, increase or decrease. So now when you're looking at this one pager, you see that, for example, low cost, weight has a somewhat of an effect on cost because shipping cost goes up with the weight goes up. That's an important of 3 to the customer. And the weight is something measured in pounds, and we want to decrease the weight. So as the weight has somewhat of an effect on cost, but we want to decrease it. So now you can kind of see the magic of the House of Quality. Now the red cup is pretty heavy, so it doesn't do a good job of meeting the customer's weight expectations. The Yeti cup is pretty light, so it does pretty good because it's made out of thin steel. And the clear cup, because it's small, it's kind of in the middle. So now you can see with one glance how weight is interpreted by the customer and what our competing products are doing and what we should be aiming to do with weight. So this is developing quite nicely. Okay, now let me start to fill this out. I'll pause here real quick and I fill out the rest of these requirements after I do 1 or 2 columns. So let's do 2 columns together, just so you guys can have an idea of what we're doing. So weight. Does weight have an effect on how nice it looks? No, absolutely nothing. It could be low weight and still look nice. Does weight have anything to do with how it fits in a cup holder? Not really. Does weight have anything to do with how this cup would work with other coffee machines? No. Does weight have anything to do with controlling the temperature where it's not too hot? No. So here immediately you can see that the effect of weight of our coffee mug is pretty minuscule to the customer, and it only affects cost. Okay. Next, does the diameter have an effect on cost? Yes, it does. So it's a huge correlation. So the bigger in diameter, the bigger of a shipping box you need, the more material you need to buy, the bigger the coffee cup is going to be. Does the diameter make it look nice? Yeah, it has an effect. You don't want to have a funny diameter to where it looks silly. Does it affect how it fits in a cup holder? Yes, 100%. If the diameter is too small, it won't fit in a cup holder. If the diameter is too big, it won't fit. And then does it have an effect on how it fits with other coffee machine? Yes. And then not hot to touch? Zero effect. Maybe a little bit of an effect. Okay, so now I'll pause the video and I go through all of these and fill this out. But this is kind of how you're thinking it. You're comparing each column to the customer requirements and filling them out. Okay, I'll be right back. All right, I took a second, went through and filled out all of the correlations between technical requirement and customer requirement, and I filled out the competitor's requirement too. Next is the actual correlation matrix here at the top. Let's go to our illustration. So this is the triangle, the attic of the house, where it correlates the individual technical requirements to one another. And now this goes back to the reason why we picked 5 cells for this. This will allow us to actually create a correlation matrix so that it looks nice. A lot of House of Qualities leave that out. So you want to click on a cell here at the corner, right click, format cell, and then add this diagonal. Okay, now that you have that, you can copy and start pasting it. Oh, let's see, sorry I did that wrong. So let's do it over here first. So you right click, format cell, throw the diagonal in. Okay, now you can copy it and start pasting it. And this is kind of a pretty manual process. So let's see how far we need to go. Okay, and you can on the other side do the diagonal in the opposite direction. Paste that, there you go. And hopefully they will meet up at the top. Okay, let's add another row. Okay, so here in the top, what you can do is you can actually create an X. So left and right, that way you show that they're merging one another. So let's highlight some of these here, copy, and then, oh, well, let's just copy this guy and then start pasting it. I'll just do a little bit of it before I skip ahead and show you how this entire thing is built all at once. So now you're starting to create your low diagonal lines. You can copy this one and start pasting it here. And whenever you have these intersections, you can format the cell and create an X. That way it looks nice. So again, copy these, paste them in here. I just kind of, when this happens, I just leave it as such. Now, this is kind of the process you'll follow, and you'll fill out the entire top. So I'm going to skip ahead again and show you what it looks like when this is completed. Okay, so I went in there and put all the formatting lines in, and like I said, where there's an intersection, if you right click, format cell, you can create that X in yourself. All right, so now you can start to create your correlation matrix, and in order to do that, you need to create some of these cells. So these vertical ones can be merged and centered, and then these horizontal ones can be merged and centered. So each individual diamond will get a merged and centered cell. So, and because we picked 5 columns, we can either do it vertically or horizontally, as you guys can see here. So I'm gonna pause real quick until I merge and center all of these, and I'll be right back. So again, to recap, I've went in and formatted these lines to actually create the attic of the House of Quality, and I've merged and centered a cell inside each one of these diamonds. And here's what I'm going to do. I'm going to highlight all of them, and missed one right here. So merge and center. And sorry, this is kind of a manual process the way we do it, but once you make a template, this should be pretty straightforward. So you go in and highlight all of these, and all of them together will go back and do the data validation from the list that we've created. And that list is in here: the positive correlation, strong positive correlation, negative correlation, or no correlation. So hit OK. And now you can start filling the top out. Now let's do that together here while we are at it. So how does the weight correlate with the diameter? Well, as the diameter increases, so does the weight. That is a strong positive correlation. Let's make all these cells here. Let's make them centered. So between weight and diameter, there's a strong positive correlation. Between weight and height, there's also a strong positive correlation. Between weight and volume, strong positive correlation. But between weight and material, there is still a strong correlation. So now you kind of see that as soon as you start messing with the diameter, the weight will change. As soon as you start messing with the height, the weight will change. Now, what does the diameter? Okay, let's finish the weight. Weight with thermal conductivity, those guys have no correlation. That's blank. Weight with color, also no correlation. Let me zoom out a little bit. Okay. Now, how does the weight affect the height? Well, that is, how does the diameter affect the height? Very little, maybe some. You don't want it to look funny. So as the diameter goes up, the height will naturally go up. As the diameter goes up, does that affect the volume that the cup can hold? Yes, strong correlation. As the diameter goes up, does the material change? No correlation at all. As the diameter goes up, will the thermal conductivity change? Not really. As the diameter goes up, will the color change? No. And let's do that with height, volume, and the rest. So as height changes, will the volume change? Yes, of course, strong positive correlation. As height changes, will that have an effect on material choice? No. As height changes, will that have an effect on thermal conductivity? No. As height changes, will it have an effect on color? No. And volume and material, as volume changes, does it have an effect on material? No. Volume to thermal conductivity? No. Volume to color? No. Material next. So material to thermal conductivity, yes. So there's a high correlation between material selection and thermal conductivity, but material and color have maybe a slight correlation, because maybe you can't anodize stainless steel a certain color. I mean, if it is see-through, that's an effect of the material, right? So that's technically a color. Okay, and then thermal conductivity has little effect on color. So now, here's your relation matrix that you've completed. So this is the top room number 3. Okay, again, now that you're seeing this, as your room number 3 completed, it starts to tell you a little bit of a story. You see this kind of clump of correlation that weight, diameter, height, and volume are related. So that's one singular unit. So these have direct correlation with one another, and that's just the geometry basically. And then the next thing is how material and thermal conductivity and color are correlated. So that's another clump of requirements or technical requirements that correlate with each other. So basically, when I see this, this is the story that it tells me. I can control the shape and control the material. As long as I control the shape and the material correctly, I will have a successful cup. And so this is the correlation matrix added to the house of quality. All right, now let's start putting together the importance ranking down here, technical assessment, and target values. So important ranking, let's see, let's put that from this cell to this cell, merge and center. There's kind of 3 of them. So this is the absolute importance. And then we have the relative. And then also the importance ranking. And these are for us here in light blue. So let's go ahead and give it that light blue color. Let's do a quick spell check while we're at it. We haven't done a spell check in a minute. All good. Merge and center these. Okay, and all of these guys are supposed to be light blue as well, because that is room number 5 here of our house of quality. Okay, how is absolute importance calculated? Absolute importance is calculated when you take the correlation, multiply it times importance, plus the correlation times importance. So you do that for each individual row. So when it comes to absolute importance of weight, you multiply the correlation of weight, how it relates to cost and how important that is. Weight compared to looks, how important that is. So you just do this. So let me put that in the formula right here. So equal this cell times this cell, and we want to keep this value consistent throughout. So as we shift to the right, we'll switch columns, but this column will never change. So what we want to do is we want to go up here. Let me shrink that a little bit. So put a $sign for this guy and a $sign for this guy. Okay. Plus this times this plus this times this plus this okay. Now all of the Q's get the $sign in front of them. That way we are not changing this cell. That cell stays consistent, since that is the absolute or the importance rating of the customer. Okay, so these are fixed and these can vary, so I hit enter. So this is basically 3 times 3 plus 0 times 4 plus 0 times 4 plus 0 times 5 plus 0 times 2. The answer is 9. So now that you fill that out, you can do that with all of these guys. And from this glance, you can quickly realize that the diameter is kind of important. Now the next thing is, how do you do the relative importance? So the relative importance is going to be the percentage of what's, so like the total amount of these compared to what percent each individual one is. And you can basically do it as such. So you take 9, so this cell here, divided by the sum So let's put a parentheses in here. The sum of all of these, parentheses, parentheses. Oh, okay, yeah, there's a parentheses missing. And let's see, for this equation here, we want to put a $sign in front of this complete sum because that will never change. So let's hit enter. So this is a percentage. Let's reflect it as such. Click this % button. So that's 2% of our total. Okay. And we can give this a nice format. Oh, I think there was a mistake with our formula here. We want to also put a $sign on these guys as well. That should make more sense. Okay. Let's make this clear or white again. And then what I like to do, well, we can keep it blue. I'll change my mind. We'll keep this blue. And then what we can do is conditionally format this as color bar. Let's give it a red. And this is 26%, so this shouldn't be all the way full. So let's go back to the conditional formatting. Color bar, more rules, and maximum. Let's make that a given value. Let's make the maximum 1. And change the color on us, so easy peasy. Let's make that red again. Okay, so the relative importance, if you format it as such, tells you a story. It tells you that weight is 2% of your total requirement. The diameter is 1/4 of it. Height is 1/4 of it. Volume is 1/4 of it. Material is 1/4 of it. Thermal conductivity is 1/10, and color is 1/10. So basically what it means is it doesn't really matter what the weight of your cup is going to be at the end of the day. Now, is that self-evident? If you did your analysis correctly, then yes, then it should say. Now, the most important things is diameter, height, volume, and material. And thermal conductivity, because it's less important than material, is a byproduct of the material choice. So you should spend your effort on these guys. That's what the relative importance is telling you. And if you want to do an importance ranking, you know, 1 through 7, you know, for here it's kind of evident, but you know, if you had more requirements, I'll show you what the formula for that is. So you do equals rank dot average, and then you pick this cell, okay, put a comma in, and then you highlight all of these guys, okay, comma, 0, and you want to put a $sign moving up here to keep that part from changing. Put a $sign on each one of these from beginning to end. Okay, so this is rank 7, and oopla. This one did not need a $sign. The first one did not. The other guys did. Sorry. Okay, let's do that again. So this is your first requirement. Diameter is most important. Your other 2 requirements, tied for each other in second place, are height and volume. Your third requirement doesn't exist. Your fourth requirement is the material. So if you focus on these top 3 materials, you should be doing pretty good. So now that you see the importance ranking is held true to what our customers want and what our research tells us and what our requirements tell us. So all these things make sense. Now you can add your target values and your technical difficulties. So let's do that next. Okay. Let's take another look at this house of quality. Yeah, you see, so far we're doing pretty good. We've got the customer, competitive customer guys in purple. We have our requirements here in red, customer requirements here in light blue, with the importance ranking in green. We have the room 0 for the qualification of the requirements, units, improvement direction. We have the correlation matrix at the top, and we have our importance ranking. Now let's do technical assessment. And then finally, the target value. Hold on, I gotta copy and paste real quick. All right, merge and center. Oh, that was yeah, these were already merged and centered. Let's give them an outline. So this is in also red. And then the value that we're aiming for, that is green. Let's do a darker green. Okay, so the technical assessment is on a scale of 1 to 10, and that will come from our list that we made at the very beginning. How hard is it to control the weight? I mean, not really, we don't care. The diameter will be difficult to control, making sure that it fits. The height is less difficult. The volume, that will be probably the most difficult thing, making sure that a cup has the correct volume. Material selection will also be pretty darn difficult, making sure that it meets all of our requirements in terms of thermal conductivity. So a lot of effort needs to be spent optimizing the volume and selecting the right material. Thermal conductivity, I think that is going to be a function of the material, and the color is easy breezy. Anyone can pick a color. Well, let's say it's not easy breezy. Depending on the material pick, you have to think about what kind of colors will actually work with the surface that you've created. So what are some of the target values that we should be aiming for weight? Obviously we don't have one, so let's leave that there. The diameter, let's say you would go and find out that every cup needs to be at least 4.3 inches in diameter for it to work in all the cup holders and machines. The height can at the most be 6 inches, but it can't be less than 2 because the volume or the handle won't fit. So let's give this a value of 6, and then the volume needs to be, let's say if you want a 12 ounce of coffee in our cup, based off of the research that we've made and compared. The material choice, we want it to be ceramic, like the red cup. So, and then thermal conductivity is not the best for ceramic, but we can't meet that. So let's say we want to do arbitrary 200 kilowatts per meter squared, and the color is going to be pink because that's who our customer is. So now you have this one pager, and I guess we can delete this reference. So let me zoom out. Okay, you have this one pager and it has excellent amount of information that summarizes basically all of your entire market research and customer research together in one page, and helps guide engineers in what trade-offs to make, what requirements to focus on, and how important these requirements are compared to one another. With this, you should be more confident in designing a coffee mug that actually meets customer requirements and can do good and sell. Now, this is an extremely simple one. Once you build your first one, it's a template. You can use it and iterate on it for different products. So this is kind of the house of quality in Excel. Excel is an extremely useful tool, readily available, and anyone can do this, so you don't need to spend a lot of money on expensive software. I think the hardest part is maybe creating the correlation matrix here at the top, but I showed you how to do that. So this is a decent house of quality that you guys could build for yourself if you followed my instructions in the previous. Okay, so that was how to build a house of quality for a simple coffee cup, looking at maybe 5 customer requirements and 7 technical requirements. Let's go back through this slide here. So it is pretty complicated to guess what the customer wants, even if you do your proper market research. So the house of quality is a one-pager that summarizes things for you. Now, the reason why you should do this is because the house of quality allows you to think and break up your thinking into one objective decision at a time. It allows you to compare customer requirements to the things that you control, which are technical requirements, one thought, one step at a time. And the idea is that if you break your thought process into these deliberate, controlled, singular decisions, that the outcome that you'll get is going to be closer to what the customer wants compared to what you or anyone else in the design process thinks it's best. At the end of the day, the point of the product is to sell it to the customer, so their opinion matters the most, and the house of quality is something that we utilize to extract that information out of the customer. Now, going back to the Ultimate Product Development Guide, section 3.4, that was house of quality we talked about. There is 17 other steps that you could be following with many sub-steps and individual tidbits. This Ultimate Product Guide is free to download on our website. It's just a PDF of a single sheet, and you can read through this and see what some of the things are that your product needs or some of the things that your product has missing, and this will help guide you create the ultimate product with hopefully more success than otherwise. Anyways, thanks for listening in, and until next time.